Hi, in this video, you'll learn how to code data for LCT dimensions using the UAM Corpus Tool. You'll then learn how to take your coded data and turn it into a wave chart using Microsoft Excel or Google Sheets. Let's begin. First, you need to load your data and an LCT coding scheme into the Corpus tool. To do this, you'll collect your data and convert it into a text file with the .txt file extension. For this video, I am going to select the first two paragraphs of the Wikipedia entry for Carmen Sandiego and copy it into a text file. These two paragraphs, which function as the classification stage of a report on the character, are interesting from an LCT perspective because, as part of a Wikipedia entry, they have to carefully navigate introducing the topic to an audience that doesn't know about it while also dealing with the complexity of a vast in-universe characterization of Carmen. So, now to import the text into the Corpus tool, I'm first going to create a new project. Then I'm going to extend my corpus and select my text from my desktop. And then finally, incorporate the file. Next, you need to import your LCT coding scheme by creating a new layer. You can get LCT coding schemes from the LCT North America or the UAM CT users Facebook groups. For this video, I'll be showing you how to code for epistemic semantic density, or ESD. I will download the ESD scheme file to my desktop. And then import the scheme into the Corpus tool by creating a new layer. I'm going to name my layer ESD. I'm going to select manual annotation. And then I'm going to reuse a user-specified scheme. I'm going to select the ESD scheme file from my desktop. And then hit continue. And I'm going to select the segments option and then select no on the remaining choices. Then I'm going to create my layer. Now I'm ready to start coding. The second step, you need to code your data. To code your data in the Corpus tool, first open the annotation window in the LCT layer. In this case, I'm going to open my ESD annotation window. To code the data, you drag your cursor along the unit of meaning that you want to code. For this text, I'll be looking at wording only. I'm going to select the text, then click on the type of ESD I want to assign to that text. So in this text, the first word that stands out is edutainment. Reviewing my choices in the wording box below, I can choose between technical and everyday. A single click will reveal the gloss for that type of ESD, which can aid you in coding. A double click assigns the type of ESD to that unit of meaning. After reviewing the two glosses, I think edutainment is a technical. If I make a mistake or I want to change this later, I can undo my choice by double-clicking the choice in the selected box. I can continue to assign types of ESD depending on how granular I want to get. For this text, I've chosen to analyze the text down to the subtype, which is deep into the wording tool as you can go. Edutainment is a conglomerate made up of edu and tainment. In this noun group, it functions as a property of the game. So I'm assigning it conglomerate properties. To speed things up, I'm going to continue to the next step with an already completed analysis of this text. The third step is export your data. So to do this, I need to save my codings. And then I will close out my annotation window and go to the project menu. And then I'm going to select Export Layer. I'm going to make sure that I've selected the layer that I want to export, which is ESD. And then I'm going to select the tab delimited format. And finally, I want to have a separate file for each text file. The tab delimited format will allow me to open the file in a spreadsheet program like Excel or Google Sheets. This exported layer should now be in my exported folder in my Corpus Tool project folder. To access it, I'm going to open it in Excel. I'm going to accept the standard formatting. And there we go. to format my data. In Excel, we can see that the rows represent each word that was coded. There's one row for each word. And the rows are organized according to their order in the text. So the rows roughly correspond to the text time, which will be important for later. Second, we notice that the columns represent the different types of ESD. The choices we made in the coding are now represented with zeros and ones. There's a 1 in the cell if that column's ESD type was selected for that row's word, and a 0 if that ESD type was not selected for that row's word. But as you can see, I've got so much data here, it's kind of overwhelming. So what I'm going to do is delete everything except for the most granular level of ESD, which is the only thing that I am interested in for my chart. Okay. Okay, so now that I have cleaned up my data and I have a more manageable data set, I can create a chart from it. To do this, I'm going to need to assign each type of epistemic semantic density a number that corresponds to its strength. Normally we use pluses and minuses, but to make a chart in Excel, we're going to use numbers. We'll assign these numbers to the different ESD types in a row above the first row. So go ahead and insert a row above the first row. To decide on what number to assign each level of ESD, start with finding your weakest ESD type and assign it a 0. This will be the x-axis on our chart. Then move one step up in ESD and assign that type a 1. Then move one step up and assign that step a 2. Continue this until you've assigned all types of ESD, or whatever dimension of LCT you're working with, a number. The weakest type of ESD should be assigned a 0, and the strongest type of ESD should be your maximum number. In this case, our strongest type of ESD is assigned a 7. I'm now going to write a simple but lengthy Excel formula using the if function to assign a strength number to each word. The if function has 3 parts to it. The thing you want to test, what should happen if the test returns a true result, and what should happen if the test returns a false result. The test we want to run is, does this cell have a 1 or a 0? In other words, we want to test each word, see what type of ESD it is enacting. If the test returns a true result, that is, if there is a 1 in the cell, because we selected that type of ESD for that word, then we need to assign that word the number that represents the strength of its epistemic semantic density, which we put in this top row. If the test returns a false result, that is, there is a 0 in that cell because we selected a different type of ESD for that word, we want the function to move on to the next type of ESD and then run the test again. So the function will be written as follows. I'm going to zoom in here. I'm going to put my if function in the T column because I want to reserve the S column for my x-axis data that will add in a few minutes. So I'm going to start here with equals and then the if function, parentheses, and then I want to select the cell that starts with the first word in my data set and corresponds to the highest level of ESD, in this case K3. And I want to know if K3 equals 1. If it is, then I want to assign it a 7. If not, then I want to run the test again and move on to L3. And if L3 equals 1, then I want to assign it a 6. If not, then I want to run the test again. And then we continue until we have gone through each level of epistemic density. Don't forget to include an if function. For this last one, I'm not going to put any kind of false condition. I'm just going to leave it blank. What will happen is if there is a false return on the function, which might happen if I forgot to code a particular word, it will just return the word false. You can correct your errors by adding a 1 or a 0 in the column that you think best represents the kind of ESD or whatever LCT dimension you're working with. Close your parentheses. Hit enter. I'm now going to drag the box for this cell down to the end of the data, and this will fill in the if function down the entire column. So I select this, go to the bottom right, make sure that there is a plus sign, and then drag it down. I'm going to label this column ESD strength. Now I want to check my data for some breaks to see if there were any breaks in the ESD. When I checked my data previously, I noticed that there is a paragraph break that does change topics significantly from here to here. So it'll be after the word theft and before the word Carmen Sandiego. So I want to find that in my data set. That's right here. I'm going to insert a row. And this will create a break in the wave chart. The last thing that I need to do is create an x-axis that roughly corresponds to the text time. This x-axis is going to be helpful so that I can cross-reference a particular point in the wave with a particular word row in the spreadsheet. To create my x-axis, I'm simply going to type the word 1 or the numeral 1, hit enter, type the numeral 2, hit enter, then select both of these and then fill down. It's important that you do your breaks before you create your x-axis so that there is a number here in the break row. Otherwise, your wave chart may be skewed. The fifth and final step is to create the chart. First, I want to make sure the text time column is to the left of the ESD column because the text time column is going to be my x-axis. Then I select my data and create a chart. I go to Insert, and I want to select a smooth scatter plot. If you do this in Google Sheets, you can do a comparable chart using the smooth line chart. Now my chart should be generated automatically, as you can see. The last thing I want to do is to change my y-axis values to pluses and minuses instead of the numerical values shown here. Unfortunately, there's no simple way to manually edit the chart y-axis values so that it contains only text values. So we're going to cheat a bit and simply cover those y-axis values up with text boxes that include the proper plus and minus symbols. After I have completed this, I can select the chart and the boxes and group them all into one object. Make sure that your fill is white or whatever your background is for the chart so that it covers up the number. I'm not confident that this is the correct number of pluses and minuses, but we will find that out. Let's see, so this will be 0, and then 1 minus, 2 minus, 3 minus, yeah, that was wrong. This needs to be a 4. This needs to be a 3. This needs to be a 2. One. And then I'm going to simply put a blank text box there. And I'm going to put a blank text box here. I now have an ESD wave chart. You can see on the bottom, we have the x-axis that corresponds to text time, which allows me to cross-reference any particular point in the wave with a particular word in the data set. I can now copy this and paste it anywhere, like a Word doc. Notice that if you're using Excel, those pluses and minuses simply come over and you do not need to group them. And now you have created an ESD wave chart.